So hi everyone, I'll just actually carry on from that last talk. The idea of how it's simple is to write modules. Inside Atlassian we have something called Ship It, which is our one-day, 24-hour hackathons, and I banged together a Jira module for Ansible and got it completed, tested, out the door, and pull requested, and I think about 2 days later it was in core, so that's actually how easy it is. So I can completely, back that up. So anyway, so we're going to talk about continuous deployment for a blank order system. The blank being because, I don't know if you're aware, Atlassian went public recently. This was written before then. I'm not allowed to use big numbers in presentations anymore. And legal are going to cut my throat now. But suffice to say, it's actually the numbers are out of date and somewhat misleading, but suffice to say that we have an order system we wrote internally, and it has processed a lot of money over the years. How much? You can just read our filings nowadays. So the background to this talk is we have this order system, and it's called HAMS for historical reasons. We also have our own ordering system we built internally for historical reasons. Historical meaning it seemed like a good idea at the time, we're not so sure about it now. But the upshot was, at the time, we didn't have anything that would fit our needs, so we ended up writing our own. And it grew from very small beginnings as basically a hack onto the existing website to just basically take people's details and we'd send them a license, through to a fully transactional, end-to-end distributed system. The system has actually been in production for well over 8 years now, and it actually works reasonably well. But the problem is it's grown somewhat crufty over the years, and in particular, as we're coming up to the IPO, suddenly we had things like SOX compliance to worry about, which is always a bit stressful, and other such changes we're going to have to put in. I think PCI compliance, and we basically need to rip the whole system apart and put it back together again in a way that is compliant with the needs of a public company. So we need to change it. We need to change it rapidly. We're a small team, but we're growing massively at an incredible rate. We went from about 2 developers to 30 over the course of about a year. So the rate of change was quite high. We want to get that change out there. So we were basically doing releases once a week. We wanted to go to release it on a regular basis. And we also wanted to release things in a much more fine-grained way. And I'll talk a bit about what that means in a few minutes. So we decided to move to a continuous deployment architecture. So this would allow us to speed up the number of changes that we were getting out and reduce risk by pushing less out with each release. The thing is, at the time, continuous deployment was an idea that was being accepted, but there was very little information about how you actually do this. I mean, it's also about why, and a little bit about the development process, but not very much about how do you actually get shit off a developer's machine or a Git commit through to actually being out on a production server in a practical way. So this talk is about that process and what the solutions we came up with. They don't necessarily be 100% applicable to your environment or your development organization, but hopefully it will give you enough guidelines to help you along the way and save going through some of the problems we went through. Luckily, one of them you probably don't have, which was choosing a deployment distribution system, as we went with Ansible in the end, and we'll talk about that briefly, but that is hopefully one problem you won't have along the way. But to start with, let's talk a little bit about continuous integration, continuous deployment, and what we actually mean by that. So at the beginning, we had continuous integration. So continuous integration is the building and testing and possibly running of every change that goes into the system. In the old days, in the days of extreme programming, pre-Agile, before Agile became an enterprise thing, it was basically building once a day, which at the time was a fairly big deal. Nowadays, we tend to build on every commit, and in our case, on every commit on every branch, and for us in particular, we run our full release test suite on every commit on every branch. So we're always sure that we are in a working state. So once you've got to that state, which is I think is what most people would consider a baseline of quality, we can actually start thinking about the next steps, which is continuous delivery. Continuous delivery doesn't actually mean exactly what it says. It means keeping your code base in a state where it is deliverable. You don't necessarily push it out the door each time, but you have a commitment to say, we will never have partial features in the main branch. We'll never have partial fixes, works in progress. What goes in, is complete and it stands alone. Of course, once you've done that, it becomes pretty normal to go up to the next level and say, well, if we can deliver it on a regular basis, let's deliver it on a regular basis. Now, what regular means, again, varies a lot in individual organizations. You can go from every single commit is a full release, which is the ultimate end goal, at least for us. Or you can talk a little bit more about, well, we'll make decisions about when to release, but we make those decisions as we want to, not based on some arbitrary release window. But from beginning to end, on all of these points, the same core idea is there. It's about quality. It's about maintaining your code base and your application and your processes in such a way that you have constantly got your eye on quality. And in particular, it's an embracement of automated testing as much as possible and the simplification of human testing as much as possible. But that's a bit about what it is. The next question would obviously be, why would we bother doing this? So what pushed us to adopt this particular development model? Well, for us, one of the major reasons was we wanted to release features, not dumps. So if you have a release every Monday, and we used to do this. We have a release every a Monday. This was in Sydney, Australia, where I was at the time. We would have that window was handy for us because that was Europe and the Americas was offline. So we do a release every Monday. So whatever was ready on Monday went out on Monday. And that could be a complete grab bag of bug fixes, changes, tweaks, tests, A to B testing, anything that was ready to go out went out. But that's not really a great way to develop, and it complicates debugging systems, particularly as you become concerned about quality and concerned about being able to the traceability of changes back to the root cause. The other reason was automation. For us, continuous deployment meant automation, and particularly meant forcing us into an automated mindset. We had a bit of a hybrid system at that time. We had scripts and so on that would do the upgrades. They were originally something written, a Python hack written by me, but we gradually moved over to Ansible eventually. But at the time were a bunch of hacks, but then a human had to run them. And when you're dealing with SOX compliance, when you're dealing with a public company, you have things like separations of duty, which meant that you had to get onto the sysadmin's schedule to have an upgrade done by them, because we were no longer allowed to do our own upgrades because we were the developers, and we needed separation from the people who had access to the actual production running code. So we wanted to automate as much as possible, and continuous deployment implies complete automation. The other one was to remove the bottlenecks. As I said, getting onto the sysadmin's calendar was a complete pain, as they were dealing with their own issues with going to IPO. They're having to split the network into SOX compliant zones versus non-SOX compliant zones and all the DMZs and so on in between. So, and we'll talk a little bit about how to sell that to people in a few minutes, convince them that this is actually worth the bother of doing. But the main idea was also by automating, we would remove bottlenecks because we would be able to push a button and the code would go out there. Anything that is hard should be done more often, not less often. So, and because that forces you to remove all the cruft and the sharp edges off the process. So, having decided that you want to do this, how do you sell this internally? Who are the stakeholders? You need to identify them inside your organization and work with them, not against them. This is DevOps in its purest sense, in the idea of breaking down silos and getting everyone who's going to be affected by this change on board and aware of the implications of this, and being able to deal with the inevitable teething problems you're going to have along the way. So the first people you're going to be thinking about are the end users of the systems. Now, something like 80% of all code is designed to be used inside an organization. So generally speaking, you're going to be able to talk to these people directly, but in some cases you won't. But the end users, what do they get out of it? Well, they're pretty straightforward. They don't care too much. They want their fixes and their new features and so on there. Continuous deployment means they get them faster. If you're on a 3-month release cycle, they're going to wait 3 months. If you're on a daily release cycle, they're going to wait a matter of days or weeks until the case of when it's done, not when the release window opens. Managers, you would think would be a bit tricky, but actually they're quite easy. Managers were very, very enthusiastic and adopters of Agile. And this is really a continuation of Agile. The reason they loved Agile was it gives them visibility into the process of the software life cycle, and it shortened it. I mean, I used to work military projects, and you talk about 3 years of plans and specs, followed by 3 years of development and a year of testing, and then you find out it doesn't actually do the bloody thing it's supposed to do in the first place. If you have an agile workflow, you can actually see what's going on, and you can see how much you're going to be over or under schedule. By having a continuous release process, you can say to the higher-ups, oh, this will go out when it's ready, not we're trying to get it in for the next release window. If it doesn't make it, we're going to have to drop that feature. So they are generally not too bad about this. In fact, inside Atlassian, this was largely driven by the development managers and the department heads instead of coming from the bottom up. Developers, again, they're slightly skeptical at first, but once you explain to them that this is a continuation of Agile, and the principles of Agile include no death marches, then this is good. In particular, a very, very fine-grained release process is good for developers because you no longer have this mad dash to get into the release window, into the next cycle. You even see this in the Linux kernel process. Linus Torvalds opens up the kernel release window and all hell breaks loose, and people are throwing all sorts of crap at him that's not quite ready to go because that's when the release window is, and another one won't open for another 6 months. If your release window is when it's done, that's great. You want to spend an extra day taking a bit of time, write an extra test, make sure it all looks good, then you do that, because it means it goes out 1 day later, not 3 months later. The last one, and you'll get the most pushback here, is from admins. By the way, how many people here are sysadmins? Cool. How many are developers? Okay, so about 50-50. All right. We'll have a big fight in the car park afterwards. So I've actually been both. So I'm allowed to say what I'm about to say, but sysadmins are a pain in the ass. So they do not want this. They don't want the developers pressing buttons and shoving stuff out the door. It's a perfectly rational idea. Now, obviously, with the automation, developers have traditionally been somewhat reticent about automation. We tend to think of things in Puppet and Chef and Ansible and so on, but this is quite a new development. Sysadmins hand-managed incredible amounts of stuff until very, very recently. They're not very big on automation, but I think they've learned the hard way that they needs to be. The automation gives them some sense that, okay, we're going to do this in a repeatable way, and that removes some of their concerns. But the big reason why you can how to get sysadmins on site is very, very simple, very powerful idea. And it relies on them having good monitoring, of course. What it means is, say you've got your release goes out on Monday, you have 3 changes in the system. One is an upgrade to the PostgreSQL driver. One is a change to the database schema. The other is a new REST endpoint, which is going to be polled by the front end. This release goes out. Database load spikes through the roof. Who's responsible? We don't know. We're going to have to go back and git bisect, test, roll back, all sorts of things that are painful to do in a production environment. However, if the database schema goes out in one release, and if the driver change goes out in another, and the REST endpoint goes out in the next one, and in each release, they push a marker into the monitoring system that says, this release was done here, this release was done here, and this release was done here, and on the second release, the load spikes through the roof, you know who to blame. And sysadmins love nailing people down and make them realize they screwed up. I know, because I once caught someone using BitTorrent inside the company network, and it was the best day of my life. So that's the how to get people on site. So now you're probably going to, hey, great, right, now how the hell do we do this? So glad to see that half the people here are developers, because I'm going to talk a bit about the development workflow now. going to go through this quite quickly. Hopefully most of this is now becoming the norm and should be fairly obvious, but I'm really talking again what worked for us. Like many things like Agile, each organization tends to adopt it in different ways to their own needs. But this is a brief overview of the development workflow. This is important because you need to manage these releases. You're going to have 10 times releases and multiple streams of development going on at the same time. You need to think a bit about how you're going to manage this, and I'll explain over the rest of this talk how we're going to manage this. This is really what the hardest part is. So the first thing is that we're going to track requests. We're going to put them into a bug tracker. We make one. I'm not even going to mention its name. So what happens is every request, every feature change, every bug report, everything goes into your bug tracker. And you use the ID that it generates for you as the unique ID for that change, and that will result in a release. Now, you might want to split it up into smaller pieces, in which case you can use an epic or a parent ID and break it up into smaller subtasks. Whatever works for you, not super important. The idea is that that unique ID will result in a single piece of work which goes out the door as a complete set. Having done that, you can then split it off into a branch. This will not work under Subversion or CVS. You need good branching strategy. Anyone here still on Subversion or CVS? Oh, wow, we have completely killed that. Like one guy down here. That is awesome. OK, so I'm assuming most people are on a move towards Git. How many people are on Git here? Or Mercurial? OK, so pretty much everyone. That's pretty cool now. So that is one of the most massive, speedy sea changes inside IT I think I've ever seen. The complete adoption of a new, very different technology. So that's pretty cool. So what happens is you create a branch and you work on that branch. And that branch is tagged with the same ID as the parent's ticket that you're going to be working against. Now, so what you can do, depending on the tools you're using, the bug tracker itself may even be able to create that branch for you. The one that we sell does, others do, I'm sure. Ours is best, please buy it. But you break off your work and you treat it separately, and it runs in isolation and does not get merged until it is ready to go on, to be pulled back in. How do you know it's ready to be pulled back in? Because you're testing it constantly. Every branch, every commit gets tested. And in our case, we run the full release test suite so that we know that any given change was not going to break the systems. Now, obviously, this requires you to have a fairly comprehensive test suite. So we do everything from unit tests up to firing everything up inside containers and inside our CI environment and running the full tests with browsers and the full works. We even run things like API validation tests and everything. So it can take a while to run. That's OK. We just throw more hardware at the problem. Computers are cheap. Human beings are expensive. So you've got a fair degree of confidence that your system's not going to break in a technological sense. But software is written by humans for humans. And sooner or later, you have to get humans involved in the process for this. So one of the things we do is we do pull requests. Again, this is relying on you having a Git server or a VCS server that supports this. I fully recommend this. Again, I'm not going to name names, but we do sell one. So pull requests are our code reviews, and they are great. Our one, it will basically recommend who should be on the reviewing panel for this by looking at previous commits and see who is the domain expert for this particular chunk of code. You should also pull in any new developers, junior developers, people who are new on the team, because it's a great way to spread knowledge about code. And the discussions that happen on code reviews tell you much more than documentation or code comments or tests will ever do. It's a very, very useful tool. So, and this basically lets humans sign off. It will spot the things that an algorithmic check is not necessarily going to do. Technical debts, bad API decisions, code smell, those things that you can't quite nail down via an automated system, although things like static analyze and so on will help you along the way. And if you can use those, definitely do use those as well. So once you've got a green light on this, and in our case, by the way, all of these tests that are happening along the way, they're all talking to the pull request. The build server is pushing back to the version control server and saying, this branch is currently passing, this branch is currently failed, and it will not allow you to do the pull request until all your tests are passing as well. So that's a very powerful idea of pull requests as well. You can actually feed automated information into it as well as human information. So even if you had those static analyzers and the code metrics for lines per function went up, then you can actually force a fail on that as well. So you can force code quality as well. But let's say you've done the right thing, everyone's happy with your code, and they sign off, and you press the magic merge button inside your pull request. What happens then? In our case, it gets merged onto the master branch, which is our release branch. We don't do fine-grained, subtle changes in branches. We basically have a master branch, which is the release branch, and we have whatever the feature branches are. And that merge triggers a full release. It does a full test suite, releases it, spits out a war or wars at the end, and immediately pushes those up onto the staging server, at which point you can do things like pull in the original customer and say, have a look, does this look right? The PDF's coming out in a neat format. Does it do what you think it should do? And at that point, if they sign off on it, and you can probably get people like business analysts and anyone else you want to get involved, you can then promote it up to production. So we don't do a separate release for production. We go put it out to staging, and if staging is good, we press a magic button inside our continuous deployment server, which we sell, and that goes up onto the production server. The same code runs on the staging and production, never any changes. And of course, obviously, your staging server should be as close to production as possible. In our case, we do regular syncs of the database with only some anonymization of customer information along the way, but we try and keep it as close as possible to a production environment. So I've talked a bit about pushing things up onto servers, and this is actually the bit that I've had the least amount of information about. Luckily, in this particular case, this is going to be pretty short. When I normally do this talk, it's much longer than this, but I've been already talking to people who are converted. So the last mile, it's called, or I call it, it's a name from telecommunications. It's easy to get information across the Atlantic. There's great big fat pipes like that big. We're getting all of those little copper pipes up to your door. That's the last mile. That's the most expensive part. So in our case, we use Bamboo. Bamboo's we've got build agents. We do the build. How do we deploy it? Right, so you've probably seen this a few times before. This actually goes on a lot longer than when I normally do this talk, or I've previously have. But the first thing that people are going to say is Puppet or Chef. Whatever they're currently using inside the organization, sysadmins are going to say, we should just use Puppet. We've already got it in place. Or we should use Chef. We've got it in place. It's the wrong answer. I actually have no access to grind with Puppet or Chef. I've used them both, and they're fine. I see them somewhat complementary to Ansible. I'm not allowed to say that, but he did the whole $1 billion thing, so I think I will. So these are complementary, but the problem is with these systems is that they are eventually consistent, and that is not what you want in a deployment environment. You tell Puppet or Chef, I need, or say Puppet. I've never used Chef in anger, so I might be wrong about this. But Puppet, you say, I want the servers to look like this. Eventually they will get there. How it gets there is entirely up to Puppet. And in particular, Puppet only really works at the single machine level, or at least it did the last time I used it in any kind of way. You can think of elaborate setups where you can coordinate across hosts, but the reality is it's designed to bring a whole bunch of machines into the same state, which is not necessarily what you want. So what we want to do is bring servers out of clusters, upgrade them, test them, put them back into the cluster only when a test passed, and then only then go onto the next server or group of servers or node or region or zone or whatever you want to do. But you need coordination across hosts at the network level, and this is where the current tools normally do. We investigate a lot of the alternative tools. I go into a whole talk about this when I've talked to people about this before. I assume you've already looked at some of them, SaltStack and so on. No access to grind with any of them. We happen to go with Ansible though. So our answer is pretty simple. We have the Bamboo agent that runs the deployment job, checks out Ansible. We literally have a copy checked into our local repository, so we know that we're not going to have to pull it off. We don't install it. We pull from a tag, so we know it's in a known state. All we need is Python and a couple of baseline Python libraries on our agent, which is normally comes with most distributions anyway. We check our Ansible scripts, and then we basically use it in its simplest form to push deployments out, and it will do everything for us. We have high availability proxies, the HA proxy. Ansible, we just talk to that via its socket system, brings servers in and out of the cluster, and then we do upgrades, and we use Ansible to basically poll a set of known endpoints to ensure that it's the server is responding correctly, and only at that point we put it back into the cluster and roll on to the next one. Now, of course, when I'm talking about this, you're talking about bringing servers out of clusters and so on. One of the biggest questions you often get with continuous deployment is, does it mean continuous downtime? That depends on your organization and how your tools and servers are used and what they're used for. But the answer is generally, if it's a tool customer-facing, you will need to build your system in a high availability setup, and a clustered setup. And actually, the reason why this project for us took 9 months rather than the half a day any sysadmin or the programmer could basically hack it out in was because we had to convert our legacy system into a high availability clustered system. We ended up with 4 servers running in parallel that we would then load balance across, and we would then bring them out of the cluster and back into the cluster. And that's what took the longest amount of time to get this basically pulled into our system. Now, this isn't necessarily always the case. So this is the case for our front-end systems and our middleware, but there are other back-end systems, one that pushes invoices up to a remote accounting system, for instance. That just is a single server. We don't bother with high availability on it because all it does is the main system, the order system, pushes onto a queue. The accounting system server just pulls off a queue. So if it goes out for half an hour and comes back and it just picks up the queue again, that's fine. So we don't worry about that because it's a pure back-end system and it's purely asynchronous. But if you've got anything that is customer-facing or critical, then you will need to go to a high availability architecture, or at least be aware of the implications of the downtime you're going to produce. So the last bit I want to talk about is, I alluded to earlier, is management. You need to tie all this together. You need to manage this. If you're going to have, say, 30 odd developers, as we end up on our team, each one are working on a separate feature with maybe 45 different streams of development going on at any given point, how do you know what is in play? How do you know what is out there? How do you know when something's been deployed? And ultimately, how do you keep the users off your back? Because that's one of the things that, as a sysadmin and a developer, I really want to address. So this is where I start talking, about Atlassian specific products. This is just because this happens to be what I know and what I use on a daily basis. Insert your own favorite technology as you see fit. So I talked at the beginning about we're going to ticket-based management, but using the ticket as a unique ID. Your bug tracker is basically your UUID generator. So ideally, if your tools are working together, and we spent a lot of time doing this, but I'm sure this works with other tools as well. Ideally, these systems will talk to each other and use that unique ID as a communication handle throughout. So, for example, I mentioned that our bug tracker, we can press a button, it will create the appropriately named branch inside the stash the Git repo for you. As you can see here, the Git repo will actually push back. So we can see that particular branch has 3 commits against it and 1 outstanding pull request which has actually been merged. Inside our deployment server, we have something called deployment environments. We can identify that there is a development environment, a staging environment, and a production environment. You can add whatever environments you need. If you have a separate QA team, then you have a QA environment that you would push up to on a regular basis. So these are basically just jobs, the same as any other builds job. And in particular, here we can see we check out Ansible, we check out the scripts, and we run them, and that's pretty much how we do our end-to-end deployment. But this deployment environment, this deployment server, is again talking back to the original ticket and giving it information. So here we can see this ticket. This is a real ticket that was raised and operated on, was it by me? I don't know. But it's for HAL, which is the system that provisions our cloud environments. If you ever bought one of our cloud installations, that's the tool that's doing it. In this case, it's been deployed out onto the sandbox for a quick test. It's deployed onto the staging environment, but has not yet been approved and pushed up onto the production environment. Now, this is great, because this is all going back in the original ticket. And ideally, if you're like us, we don't raise the tickets, the customers do, or the QA do, or the managers do. And they raise the ticket and immediately come around to you going, is it done yet? Is it done yet? Is it done yet? Well, the answer is piss off, go and look at the original ticket, because all the information you need is in there. Show them that once and they'll be much happier. And particularly if they see that a branch has been created, the commits are occurring and so on, the work's being done, they're going to be happy, they're going to leave you alone. People really don't want to bug you that much, but they're kind of forced to it. No one likes being kept in the dark. So by giving all this information to the users up front, you make their life easier, you make your life easier as well. And people are generally happier. Even if it's bad news, people prefer bad news to, to being kept in the dark. The last thing we'll talk about as well is when you're doing this, in terms of a SOX or PCI compliant environment, you need something called separation of duties, and you need a strong group-based authentication system. You need to be able to separate your users out. You need to be able to say certain users can do certain things. In particular, in our case, developers can commit code and so on, but the BAs and management can't. However, the sysadmins and the BAs do have permission to do deployments which developers don't have. That's because you need separation of duties. And if they come along for SOX audit of your organization later on, that's what we're going to ask you. Show me how you separate your duties. If you show them the admin screen of your tools and say, clearly, all our developers in this group, and that does not have that permission, or our BAs are in that group, they have this permission, then you have something that is auditable, and you can then show them that, and it'll make them, their lives a lot happier. They love these automated systems because it's quite clear. I have actually heard that I saw a talk at Go to London by somebody from ING, senior manager there. He managed to get the banking regulators to accept that they didn't need separation of duties because their tools were so automated, the automated scripts themselves were considered a separation. So that you can actually remove this completely. So this is how powerful this idea can be. We have not gone that far. It will be kind of cool though. But the key points I want to talk about here, the main ideas to take away is you need a clear motivation about why you're doing this. You can't just do it because it's cool and happening right now. You should do it with a clear idea, and you should be able to communicate those ideas to people who are going to be affected by this and get their complete buy-in for when things inevitably, there are teething troubles along the way. You need to use a branching workflow, and you need to use cooperative tools, and you need to cooperate with people as well to make sure all the communication is occurring, that you have high visibility of the entire process so that you can manage this. But it is doable. It has some tricks around it. It's one of those things that it can be done very quickly, very easily, but it can also be done well, and you need to think about doing it well. But it can be done. So that's the end of my talk. If you're more interested in more stuff here, developer.Atlassian.com blog is where our team and our developer tools blog about such things. Also, if you want on similar related talks, if you do a search on the search terms up there with my internet handle against it, it might be of some interest. In particular, I've been talking recently about Docker continuous integration using Docker as a testing platform, and also about Git fundamentals. So I have some videos on the web about that as well if you're interested in these sort of topics. And also, if you're interested or a user of Atlassian tools, the Atlassian London user group is starting up again next Wednesday. There is a meetup, and I'll be talking about using Docker for continuous integration and testing if you're interested in such things. So thank you.